All right, everybody, welcome back for another deep dive.
Yeah, looking forward to this one.
So today we're going to be looking at insulation materials,
Mm,
and
yeah,
they're everywhere, right? I mean, like
absolutely.
just in our homes and our cars, but
Yeah,
like
all over the place.
they're especially important when we're talking about like energy storage systems.
Yes, definitely.
So we found this case study about this company that was developing all
Oh,
these,
cool.
yeah, all this like cutting edge stuff like electric vehicle batteries and
Wow.
solar power backups for homes and stuff.
That's awesome.
And they ran into this big challenge
Oh,
with insulation.
interesting. Okay.
Yeah. And, you wouldn't think about it at first, but
Yeah.
it was a huge problem for them.
Well, yeah, I mean, it's kind of a hidden hero, right? Insulation. You
Yeah.
don't really think about it until it's not working.
Right, exactly.
And then you're like, oh,
Yeah.
this is a big problem.
Yeah, you really notice it when your energy storage system like
Right.
catches on fire or something.
Exactly. Yeah, safety is a huge issue. I mean,
Yeah.
you've got these high voltage systems,
Right.
a lot of energy packed in there. And if the insulation fails,
Yeah.
things can go very wrong.
What could go wrong? I mean, like what?
Well, you could have, leakage currents
Okay.
that can reduce efficiency and lifespan of the system.
Right.
And then the worst case scenario, of course, is a short circuit,
Okay.
which can lead to a fire.
Yeah, that sounds pretty bad.
Yeah, it's not good.
So, okay, so this company in the case study, they were
Right.
working with all these different kinds of materials, trying to figure out
Yeah.
like what was going to work.
Mm-hmm.
And they had like ABS and HDPE polypropylene, TPE polyamide.
Wow, that's quite a list.
Yeah, they had a lot of options.
Yeah, and each of those materials has its own,
Right.
strengths and weaknesses.
Yeah.
So finding the right one is crucial.
Yeah. And so they had to test it right. They couldn't just
Oh, absolutely.
like pick one and hope for the best.
Yeah, you can't just assume a material will work. You have to actually put it through its paces.
Yeah.
See how it behaves under stress, under temperature changes, and over time.
Yeah, because like I imagine like it's got to be
Right.
durable, right? It can't just like
Exactly.
fall apart after a year.
You need something that can withstand
Right.
the demands of these systems.
So how do they test it? I mean, what do they actually?
Well, they had to meet certain industry standards.
Okay.
One of them is called ASTM D257.
ASTM D what?
D257.
Okay.
Yeah, it sounds complicated, but it's actually pretty straightforward.
Okay.
They apply a high voltage to the material.
Okay.
We're talking like 1,000 volts.
1,000 volts.
Yeah, it's a lot.
Yeah, that seems like a lot.
For a set period of time, and then they measure how much current leaks through.
Okay.
So basically, it's a stress test for the insulation.
Okay.
The lower the leakage, the better the material is at resisting
Got it.
electrical breakdown.
So what happened? I mean, did they find a good material?
They found that polyamide performed the best.
Polyamide.
Yeah.
Okay.
It had the lowest leakage current.
Okay.
But there was a catch.
Oh, there's always a catch.
It was also the most expensive option.
Of course it was.
Of course. So this highlights, a common dilemma in engineering.
Right.
Balancing performance with cost.
Okay. Yeah, that makes sense.
You want the best, but you also have to consider the budget.
So what did they do?
Well, in the end, they decided to go with the polyamide,
They did.
despite the higher cost.
Okay.
For them, the long-term benefits of superior insulation,
Yeah.
the increased safety, the efficiency, the lifespan of the system
Right.
outweighed that upfront expense.
So they were thinking long term.
Exactly.
Right.
Sometimes you have to invest a little more upfront
Right.
to get those long-term benefits.
Yeah, it's like that saying,
Right.
penny wise and pound foolish.
Exactly.
Yeah, you save a little bit now, but then later you're...
You pay for it later. Yeah.
So I guess the takeaway here is that like, insulation,
Yeah.
even though it's kind of like a hidden
Mm-hmm.
thing that you don't really think about,
Right.
it's super important for,
It's crucial.
yeah, for these energy storage systems.
Absolutely. It can make or break the entire system.
Yeah. And so next time you see like, an electric car or like a house with solar panels on it,
Yeah.
just remember that there's all this
Yeah.
important stuff going on behind the scenes.
Behind the scenes. Yeah. The unsung heroes.
Yeah, the insulation, keeping everything running.
Keeping everything safe and efficient.
Yeah.
Yeah.
Well, I think that's about all the time we have for today.
That was a good one.
Yeah. So I guess that's it.
See you next time.